You can see why I hated biochemistry. It's like way too hard. At the nanotechnology level, what allows a cell to be able to transform chemical energy into mechanical energy? And what it is special cells are a three-dimensional array of proteins that interact with each other and actually tug on each other and pull. You can see this in schematic right here. Do you think this is simple or very complex? I think you're getting the idea of this now. This is a photomicrograph of a heart cell, and if you look carefully in the pink part, you can see these vertical lines where the proteins are anchored to each other, so they have something to pull on as they contract. The two key proteins are called actin and myosin. Actin and myosin work together in order to convert this chemical energy that comes from something called ATP and calcium into mechanical energy. And the myosin looks a little like a golf club, and the end of it can move like this when it's given energy, and it pushes the actin along the x-axis here so that the cell can shorten. This is really where the complexity lies. Actin has 374 amino acids and myosin 1900. Actin looks something like this, three-dimensionally. Hugely complex. One cannot work without the other. This is an example of irreducible complexity. We don't know of any use for actin by itself. The two have to work together for there to be any function of the heart. This is something Darwin couldn't know. Another thing that he didn't know is that all the proteins that we're talking about had to have been encoded in the blueprint or DNA before the protein was ever made. Our DNA has the equivalent of an encyclopedia of information, 5 or 6 billion base pairs of binomial computer-like information that is stored inside our DNA that coded for these proteins. In addition to coding for those proteins, we also see, like this heart we're preparing for transplant here, we see that it also codes for what we call the gross anatomy, a four-chambered heart, the valves, the skeleton to keep it together, and the neural network that allows the heart to beat with regularity and with coherency. But here you see we're opening the left atrium. You look through the hole here, that's where the mitral valve lives. And all of this information for how to do this is stored inside that DNA.
The central dogma of molecular biology, as first stated by Francis Crick, asserts that information flows from DNA to RNA, and then from RNA to protein. Information never flows from protein back up the line.
Functional heart and lungs. This is a heart and lung block taken from a young man. The object of the heart and lungs, their purpose, is to exchange oxygen for carbon dioxide and pump the blood around at a specific temperature and pressure. Well, we have a machine that does something similar to that we need to do while we do heart surgery. This machine takes oxygen, puts it into the blood, takes out carbon dioxide, and pumps the blood around so that we can work on the heart. Some people liken heart surgery to working on a car engine, only the engine's still running. So it's a little like that. So we have a machine that can do the work of the heart and lungs. It looks something like this. This is the oxygen exchanger. It uses microfiber technology and allows exchange of gases like oxygen and carbon dioxide. And then the pump that monitors the pH of the blood, the temperature of the blood, and the pressure at which it's pumped back to the patient looks something like that, like this. There's a venous reservoir to hold the blood. If I let him work on Dad's heart-lung machine over time, do you think it's inevitable that the machine will improve function or will stop functioning? We know by reason and experience what to expect. We must lose function over time. Time is not your friend in the biological arena. The second law of thermodynamics does not give you any leeway in this area. The question we have to ask ourselves is, starting from our simple ribonuclease, where did the information come from? Because this blueprint, your DNA, has all this information in there already. We look a lot more like Mount Rushmore than Monkey Head Rock. Was Darwin wrong? Well, Richard Dawkins is a prolific author and a leading naturalist, and he writes a lot of books. I'd recommend you reading them. The more statistically improbable a thing is, the less we can believe it happened by chance. Superficially, The obvious alternative to chance is intelligent design. Now, what do we really mean by the word superficially? Do you mean just looking at what we can measure and see? Because when we look at what is available to us, design seems to be imprinted there. But no, let's climb Mount Improbable, Richard Dawkins says. But I think there's a problem with his initial analogy. He says, I'm standing at the foot of Mount Improbable, and I'm looking up the sheer face of a granite cliff, and at the top is, say, an eye, something very complex. And it seems very improbable that I could leap from down here all the way up to the eye in one bound and climb Mount Improbable in one leap. He goes, but what if I went around the back and climbed up the stairs a step at a time? Well, we have seen that the concept of irreducible complexity, which our bodies have, makes those small steps more like a leap to the moon than a jump across a puddle. It's not reasonable that we could take even one small step in that direction. Undaunted, he says, God is just a delusion. The central purpose of biology, according to Dawkins, is to explain why nature looks like it's designed, but actually it's not. And his colleague at Oxford, Alistair McGrath, wrote an interesting rebuttal to this book, saying, you know, this is a logical fallacy. You are exercising a fallacy called flight from the obvious. All the evidence is here, but there's some reason why that evidence isn't being accepted. A little different tack was taken by this scientist, Francis Crick. You see her on your right. As you know, he is the describer of the DNA molecule, famous scientist and Nobel laureate. And he was very troubled by the fact that there is so much complexity built into the DNA molecule. In fact, he was despairing because he couldn't explain how all that information could have gotten there. So he came up with a rival idea because he could no longer accept that chance could have implanted that information. This is what he thought. We came from outer space. He called it directed panspermia. Now, nobody laughed when he said it because he's a Nobel laureate, but he actually thought that there's no other explanation than that aliens from outer space injected us with this information and caused the biological complexity that we see. Theologians have always been tagged with thinking, oh, you guys deal on faith, not facts. But what's happening now is evidence mounts up, things Darwin couldn't know, that now science, and I use the term in a narrow sense, is in this position of having to create a mythology of its own, a panspermia of its own. Consider the heart. We look at its function, and we compare it to our attempts to create a heart. Which of these hearts is the product of time plus chance? Which one works better? Which one bears the mark of design? Now, the picture on your right shows this heart assist device in place, and it's actually attached to the patient's natural heart. We put them side by side. Richard Lewontin is a biologist from Harvard, and he says that we have to go against common sense because our struggle really is against science versus the supernatural. Here's that barrier again. Let's separate the two. And he's saying science must say, even against common sense, that time plus chance are all that we need. We'll take the side of science narrowly defined again, in spite of the absurdity of it, in spite of its failure of predictive value. And in fact, despite reason and experience, we're going to take this because we have an a priori assumption. A priori means I've made up my mind ahead of time, and I'm going to make the facts fit in to what I've already decided. A priori adherence to material causes, no matter how counterintuitive. But properly interpreted, I believe the evidence says design is there. I believe God provides a way that wall is broken down because God has revealed himself. God is there. He's not silent. He has shown himself through his creation. We've surveyed some of that evidence tonight. He says, I'm there. I'm not silent. I'm telling you that you were designed. King David knew this 3,000 years ago. He wrote, I will give thanks to thee, for I am fearfully and wonderfully made. Great are thy works. Through creation, God has revealed himself. Bertrand Russell can't say, you didn't give me enough evidence. It's there. So we go back to our basic questions. Where did I come from? Well, if the answer is that we're designed, we have evidence for that. But what about these other questions? Who am I? Why am I here? Where am I going? We can't get all those answers just from what we call a general revelation. That is, that I can see that there's design in the cells of my body. God has left us more than just evidence in creation. I believe he has also left us his word, a specific verbal revelation that says, I am the bread of life. God tells us who he is. I am the light of the world. I am the way, the truth, and the life. He's telling us about himself and desires a relationship with us, the beings that he created. If we are just the products of chance, then you know that we're just alone in the universe, cold, unfeeling, immense. You came by chance. You're going to leave without leaving a footprint. Your destiny is nowhere spelled out, and your duty doesn't exist. But what if there is a designer who desires to have a personal relationship with you? God so loved the world that he gave his only begotten Son, that whoever believes in him shall not perish, but shall have everlasting life. You see what a difference it makes? Not only where did I come from, because the evidence of design tells us that there is a designer and a creator, and his word tells us who we are, why you're here, and ultimately where you're going by your relationship to him. So tonight I would invite you to taste and see. I would invite you to go where the evidence leads. I would invite you to open your mind and allow the possibility that there is a designer and see what the world looks like when you have that paradigm. I would invite you to embrace that larger reality. Take all of reality in, and you will not be disappointed. Thank you very much.